going to prove the following theorem. You have an n by n matrix that is non-singular. This can only be true if and only if this matrix is row equivalent to In. Okay, so we have to do if and only if. That means in two directions. Now suppose we go row equivalent to In implies non-singular. That means in this case we're going that way. Okay, the proof is very standard. Let A be a n by n matrix. Actually, let's state it right here. Non-singular matrix. I didn't mean that. I apologize. A is an n by n matrix that is row equivalent to the identity matrix. Hence, there exist elementary matrices E1, E2, say up to E sub n, such that when you multiply on the left of A by E1 and E2 all the way down to En, you get the identity matrix. So En minus 1 all the way down to E2, E1 times A is equal to the identity. Therefore, the inverse of A, that is, whatever you multiply this by to get the identity, namely this, is the inverse of A. Okay, and we're done. I showed that A is non-singular. First, I assumed that A was row equivalent to I, and then I showed that it was non-singular, I sub little n. Okay, so now we need to go the other way. Oops. We need to go this way. That is, we need to show that if A is non-singular, that implies that it is row equivalent to the identity. Okay. Well, that's what we wanted to show. A non-singular implies A inverse exists such that A inverse times A is equal to the identity. But A inverse, any matrix, is a product of elementary matrices. Elementary, let's call it row matrices. Okay, so what does that mean? That means A inverse, I won't use the same letters as before, it is equal to elementary row operation 1 times 2 up to m. Okay. That is, remember, A inverse times A is identity. That is R1, R2 up to Rm times A, because this is A inverse is equal to the identity matrix. That is, A is row equivalent to, so now if you take A and you multiply it by one or more elementary row matrices, whatever you end up with, A is row equivalent to that. But we happen to end up with IN. So A is row equivalent to their n by n identity matrix. And that is what we set out to prove. We did prove it. That completes the proof. And this pretty much completes this video. First, I want to say please subscribe to my channel and leave some comments while you're at it. And as always, watch and learn. Have a great day.